Introduction to System Planning. In this video, we are going to see about Introduction to System Planning. A business is a setup to meet a mission. The mission of an organization is usually expressed as a single crisp statement that gives the purpose of the organization. An organization has various levels of management. At each level, the view, types of activities, and decisions vary. Information required varies depending on the use that information is being put to. This is also called as information system architecture or information system hierarchy. The type of planning depends on type of systems used. The types are as follows: strategic planning, tactical planning, operational planning. Strategic planning. Strategic planning is the important function of any organization. This is a long-term planning. The word strategy means a careful plan or method aimed towards achieving an objective or goal. To make sure that the organization is not deviating from its objectives and long-term goals, it is necessary to have strategic planning. Strategic plans are specific but not detailed. Strategic plans have long-term goals. The long-term goal is used to set up more detailed to short-term goals. The types of system which help in strategic planning are decision support systems, DSS, expert systems. Expert systems are also used by top management for such planning. An expert system is a database of knowledge which can be used to draw conclusions. Tactical planning. Tactical planning is also called as short-term planning. Organizations make short-term goals and need to have systems to check whether or not they are being met. Short-term planning usually expresses the objectives and goals in more tangible terms like financial results and volume of sales profits. Systems that support short-term planning are Management Information System (MIS). Analysis of the past data and the organization's long-term goals are used to set these plans. MIS draws its input from data which is already available to organizations at the operational level. By using the data of the operational systems in a more summarized form, MIS system gives the types of reports required by middle managers. Operational planning. Operational planning is at the lowest level in the hierarchy of information system. Operational planning helps in operations and day-to-day activities of an organization. Each department in an organization has information it needs to maintain, transactions that keep happening, reports and exceptions which are required to trigger off follow-up action, and other similar activities. System needs for operational planning are met by Electronic Data Processing (EDP). Operational systems are used for processing and generating regular and exceptional reports. Operational systems are used by the lower and middle level managers and the officials handling day-to-day activities like the accountants and the storekeeper. Data and fact gathering techniques. In this video, we are going to see about data and fact gathering techniques. Fact-finding is an important step for the analyst, from which the analyst gains an understanding of the existing system and its problem and finds a requirement for the new system. There are a number of fact-finding tools which the analyst uses. The analyst chooses the tools that are considered suitable and uses them to collect all the required information, which is then analyzed. Fact gathering is also called as information gathering or data collection. The following are the techniques used in fact gathering: interviews, questionnaires, group communication. Interviews. In this video, we are going to see about interviews. Personal interviews are a direct method of obtaining information from people. Analyst learns about the existing system, problems, and expectations from this information. The analyst selects the people who are related with the system for the interview. In this method, the analyst sits face to face with the people and records their responses. The analyst gets a flexible opportunity to learn various pertinent facts. The interviewer must plan in advance the type of questions that is going to be asked and should be ready to answer any type of question. Interviewer should also choose a suitable place and time which will be comfortable for the respondent. The interviewer is facing the interviewee so that the interviewer can observe the reaction of the interviewee and see how the person is responding to the questions being asked. Personal interview gives the interviewer an idea of the reliability of the information being gathered. Personal interview also gives the interviewer a chance to ask more questions along with some promising line which may not have been thought of earlier. The information collected is quite accurate and reliable, as the interviewer can clear and cross-check the doubts there itself. This method also helps gap the areas of misunderstandings and help to discuss about the future problems. The two subcategories of interview are as follows: structured interview, unstructured interview. Structured interview is a most formal interview where fixed questions are asked and specific information is collected. Unstructured interview is more or less like a casual conversation where in-depth areas, topics are covered and other information apart from the topic may also be obtained. Group communications. In this video, we are going to see about group communications. When information is required from face-to-face sessions, but there is not enough time to conduct personal interview, meetings can be held. In group communications, many persons are present. More types of ideas can be discussed in a short time. The comments of one person may prompt other person to contribute facts that may have otherwise forgotten. Conducting a group session is a skilled matter, as there are problems like The group may be dominated by some persons, and others who may otherwise have something to contribute may be shy and not speak up. Problems with seniors may not be voiced because of seniors being present. The situation may lead to a verbal fight between persons which may need moderation. Internal politics of an organization may determine what is said and what is left unsaid, thus resulting in a false picture. Questionnaires. In this video, we are going to see about questionnaires. Questionnaires is a technique used to extract information from a number of people. Questionnaires method can be adopted and used only by a skillful analyst. A questionnaire seeks information from the person in a written form and in a prescribed format against the set of questions. Questionnaires are good for gathering specific information where the questions can be structured in advance and uniformly for a number of persons. Questionnaires are useful as they are a quick means of gathering information and analyzing it together. Questionnaires are particularly useful if the respondents are scattered geographically or there are no time to hold interviews. Questions are of two types: structured, unstructured. In structured, the respondent has to select from possible options and the range of answers is limited. In unstructured, the respondent's opinion and letting the respondent answer freely, the questions are open-ended. Structured questions need more analysis and may or may not give the type of information sought. Examples of structured questions are where the answer could be yes or no type, selected from specified multiple choice, selections on a ranking scale, selections of a rating, fill in the blank. Assessing project feasibility. In this video, we are going to see about assessing project feasibility. Feasibility study means to check whether the proposed system is feasible or not. Feasibility study is an analysis of the viability of an idea. Feasibility study can be used in various ways with focus on the proposed business. Feasibility study tells us whether a project is worth doable or not. Feasibility study is a must because every project is not doable. Not every project should be done. Not every project makes use of effective resources of company. In its simplest terms, the two criteria to judge feasibility are cost required and value to be attained. A well-designed study should provide a historical background of the business or project, a description of the product or service, accounting statements, details of the operations and management. There are three categories of feasibility test. They are as follows: economical feasibility, technical feasibility, operational feasibility. Technical feasibility. In this video, we are going to see about technical feasibility. Technical feasibility is concerned with assessing the development group's perception of the possible target hardware, software, and operating environments to be used, in addition to the system size and complexity. The technical requirements of system will differ considerably, but will generally include the following: The capability to generate output in a given time scale, for example, 10,000 products in a month. The capacity to provide certain response times under certain conditions, for example, 3-second response time at each workstation when there are 6 workstations working in parallel. The facility to input a large number of documents in a limited time scale, like number of bills per day, examination answer sheets, etc. The ability to process a certain volume of transactions at a certain speed, for example, to provide the seat availability or reservation information to the passengers in a limited time. The facility to transfer or send data to distant locations. While assessing technical feasibility, the configuration of the system is more important than the actual make of the hardware. The configuration should depict the system's requirements, for example, how many workstations are provided, how these units should be able to operate and communicate, what input and output speeds should be achieved, and of what print quality. Specific hardware and software products can then be assessed in the context of the logical needs. Operational feasibility. In this video, we are going to see about operational feasibility. Operational feasibility deals with human, organizational, and social aspects. Its purpose is to gain an insight into the degree to which the proposed system will solve the business problems. The questions that find answers in the assessment of operational feasibility are: what job changes will the system bring? People are inherently resistant to change, and computers have been known to facilitate change. An estimate should be made of how strong a reaction the user staff is likely to have towards the development of a computerized system. What organization structures are impacted? What new skills will be required? If the current employees do not possess these skills, how long will they take to learn the same? The operational feasibility deals with the willingness and capability of users to use and benefit from the proposed system. Economical feasibility. In this video, we are going to see about economical feasibility. Economic analysis is carried out to determine the benefits and savings that are expected from a candidate system and compare them with costs. If benefits outweigh costs, then a decision is made to design and implement a system. Otherwise, further alterations in the proposed system are made to improve its economic viability. Many organizations assess projects on an economic basis alone, that is, they must show financial returns that exceed the costs. Therefore, management gives more importance to economic feasibility than to technical and operational feasibility. Typical benefits and costs resulting from the development of an information system are described in the subsequent sections. Ascertaining system benefits. A system can prove to be highly beneficial to an organization. For example, a new information system can mechanize jobs, reduce errors, provide new and improved services to customers, and enhance organizational efficiency, speed, flexibility, and morale. Benefits can be categorized into tangible and intangible benefits. Tangible benefits refers to items that can be measured in quantitative terms. For example, reduced manpower expenses, lower transaction costs, etc. Intangible benefits refers to items that cannot be measured or quantified easily. For example, improvement of employee morale. Lists some of the tangible and intangible benefits from implementation of an information system. Ascertaining system costs. An information system can have both tangible and intangible costs. Tangible costs are those items that can be measured easily and with certainty. Intangible costs, on the contrary, refer to items that cannot be quantified or measured easily. Several guidelines that have been identified for improving the cost estimating process, which forms an important part of system development. Some of the guidelines are as follows. Finalize the initial estimates after thorough study. Control user changes. Check the progress of the proposed project. Evaluate the project personnel using the estimate. Consider the cost estimate carefully before approving it. Base your judgment on documented facts and figures and not on intuition. Information system related development costs can also be characterized as either one-time or recurring. One-time costs are related to project initiation and development and startup of the system. For example, new hardware and software purchases, user training, site preparation, etc. These expenses should be documented when conducting an economic cost-benefit analysis. Recurring costs are a result of continuous development and use of the system. Cost-benefit analysis. In this video, we are going to see about cost-benefit analysis. Cost-benefit analysis (CBA), also called as benefit cost analysis (BCA), is a systematic approach to estimate the strengths and weaknesses of alternatives that satisfy transactions, activities, or functional requirements for a business. Cost-benefit analysis is a technique that is used to determine options that provide the best approach for the adoption and practice in terms of benefits in labor, time, and cost savings. The CBA is also defined as a systematic process for calculating and comparing benefits and cost of a project. Costs fall into two categories. There are costs associated with developing the system, and there are costs associated with operating a system. The former can be estimated from the outset of a project and should be refined at the end of each phase of the project. The cost of developing an information system can be classified according to the phase in which they occur. System development costs are usually one-time costs that will not recur after the project has been completed. The flowchart of benefit cost analysis. Many organizations have standard cost categories that must be evaluated. In the absence of such categories, the following list should be of help. Personnel costs, computer usage, training, cost of any new computer equipments and software. Personnel costs. The salaries of system analysts, programmers, consultant, data entry personnel, computer operators, secretaries, and the one who work for the project is personnel cost. Many of these individuals spend time on many projects. Their salaries can be prorated to reflect the time spent on the project being estimated. Computer usage. Computer time will be used for one or more of the following activities: programming, testing, conversion, word processing, maintaining a project dictionary, prototyping, loading new data file. If a computing center charges for usage of computer resources such as disk storage or report printing, the cost should be estimated. Training. If computer personnel or end users have to be trained, the training courses may incur expenses. Operating system cost. The system will incur costs even after it is operating. The lifetime benefits must recover both the developmental and operating costs. Unlike the system development costs, operating costs tend to recur throughout the lifetime of the system. The cost of operating a system over its useful lifetime can be classified as below. Present value analysis, net present value, payback analysis, break-even analysis, cash flow analysis, present value computation. Present value computation discounting is done to compare the money with what would have been earned if the money was put in some other projects. Present value analysis. The present value analysis, when carried out for the net benefits, is called the net present value (NPV). Time value of money is used for both costs and benefits. Payback analysis. Payback analysis is used to determine when the accumulated benefits equals the initial investment. This period is called as payback period. The shorter the period, the faster the profits of new system start to flow and the more attractive the project seems. Break-even analysis. Break-even analysis compares the cost of the current system to the new system. A new system has a larger investment in the beginning, whereas the current existing system incurs operational cost. The cost per transaction will be lower than that of the old systems beyond some volume. This is called as a break-even point. Cash flow analysis. Cash flow analysis cash flows out when money is spent and is received with revenues and earnings. By tabulating both the outflow and the inflow of cash expected over a period of time, a clear picture is obtained. It also gives an idea of how much cash will be needed to get the new system going. The point where the accumulated cash flow turns positive is the payback period. Schedule feasibility. In this video, we are going to see about schedule feasibility. The process of assessing the degree to which the potential time frame and completion dates for all major activities within a project meet organizational deadlines and constraints for affecting change. Another feasibility concern relates to project duration and is referred to as assessing schedule feasibility. The purpose of assessing schedule feasibility is for you, as a system analyst, to gain an understanding of the likelihood that all potential timeframes and completion date schedules can be met, and that meeting these dates will be sufficient for dealing with the needs of the organization. For example, a system may have to be operational by a government-imposed deadline by a particular point in the business cycle, such as the beginning of the season when new products introduced, or at least by the time a competitor is expected to introduce a similar system. Further detailed activities may only be feasible if resources are available when called for in the schedule. The illustration of schedule feasibility. For example, the schedule should not call for system testing during rushed business period or for key project meetings during annual vacation or holiday periods. The schedule of activities produced during project initiation and planning will be very precise and detailed for the analysis phase. The estimated activities and associated times for activities after the analysis phase are typically not as detailed. For example, it will take 6 weeks to program the payroll report module, but are rather at the lifecycle phase level. That is, for example, it will take 6 weeks for physical design, 4 months for programming, and so on. This means that assessing schedule feasibility during project initiation and planning is more of a rough-cut analysis of whether the system can be completed within the constraints of the business opportunity or the desires of the users. While assessing schedule feasibility, you should also evaluate scheduling trade-offs. For example, factors such as project team size, availability of key personnel, subcontracting or outsourcing activities, and changes in development environments may all be considered as having a possible impact on the eventual schedule. As with all forms of feasibility, schedule feasibility will be reassessed after each phase when you can specify with greater certainty the details of each step for the next phase. Legal and contractual feasibility. In this video, we are going to see about legal and contractual feasibility. The process of assessing potential legal and contractual ramifications due to the construction of a system. A third concern relates to assessing legal and contractual feasibility issues. In this area, you need to gain an understanding of any potential legal ramifications due to the construction of the system. Possible considerations might include copyright or non-disclosure infringements, labor laws, antitrust legislation, which might limit the creation of systems to share data with other organizations, foreign trade regulations, for example, some countries limit access to employee data by foreign corporations, and financial reporting standards, as well as current or pending contractual obligations. Contractual obligations may involve ownership of software used in joint venture, license agreements for use of hardware or software, non-disclosure agreements with partners, or elements of a labor agreement. For example, a union agreement may preclude certain compensation or work monitoring capabilities a user may want in a system. A common situation is that development of a new application system for use on new computers may require new or expanded and more costly system software licenses. Typically, legal and contractual feasibility is a greater consideration if your organization has historically used an outside organization for specific systems or services that you now are considering handling yourself. In this case, ownership of program source code by another party may make it difficult to extend an existing system or link a new system with an existing purchased system. Political feasibility. In this video, we are going to see about political feasibility. The process of evaluating how key stakeholders within the organization view the proposed system. A final feasibility concern focuses on assessing political feasibility, in which you attempt to gain an understanding of how key stakeholders within the organization view the proposed system. Because an information system may affect the distribution of information within the organization, and thus the distribution of power, the construction of an information system can have political ramifications. Those stakeholders not supporting the project may take steps to block, disrupt, or change the intended focus of the project. In summary, depending upon the given situation, numerous feasibility issues must be considered when planning a project. This analysis should consider economic, technical, operational, schedule, legal, contractual, and political issues related to the project. For example, project may be selected for construction despite high project costs and high technical risk if the system is viewed as a strategic necessity. That is, the organization views the project as being critical to the organization's survival. Alternatively, projects may be selected because they are deemed to require few resources and have little risk. Projects may also be selected due to the power or persuasiveness of the manager proposing the system. This means that the project selection may be influenced by factors beyond those discussed here and beyond items that can be analyzed. Understanding the reality that projects may be selected based on factors beyond analysis. Your role as a system analyst is to provide a thorough examination of the items that can be assessed. Your analysis will ensure that a project review committee has as much information as possible when making project approval decisions. The illustration of political feasibility. Methods for determining system requirements. In this video, we are going to see about methods for determining system requirements. Requirement determination and requirement structuring are two core components of system analysis. Traditionally, interviewing, questionnaires, directly observing and analyzing documents are four main methods adopted by a system analyst to collect information. Joint application development (JAD) and prototyping are two modern requirements determination methodologies. A well-structured representation of system requirements can dramatically improve the communication among analysts, designers, users, and programmers. Analysis is the first SDLC phase where we begin to understand in depth of the needs for a system. Analysis can be divided into three main activities: requirement determination, requirement structuring, alternative generation, and selection. Requirement determination is the beginning subphase of analysis. In requirement determination, analysts should gather information on what the system should do from as many sources as possible. There are some traditional methods to help collecting system requirements, such as interviewing, survey, directly observing users. Modern requirements collecting methods are JAD and prototyping. Joint Application Development Program. In this video, we are going to see about Joint Application Development Program. JAD is a facilitated, team-based approach for defining the requirements for new or modified information systems. The main idea behind JAD is to bring together the key users, managers, and system analysts involved in the analysis of a current system. Joint application development is better than traditional techniques because it will have all key personnel in one place at one time. Joint Application Development, or JAD, is a structured process in which users, managers, and analysts work together for several days in a series of intensive meetings to specify or review system requirements. The primary purpose of using JAD in the analysis phase is to collect systems requirements simultaneously from the key people involved with the system. The result is an intense and structured but highly effective process. The typical participants in a JAD are JAD session leader, end users, business managers, sponsor, system analysts, IS staff. The JAD team is a group of from 6 to 16 individuals who all have a skill in designing a high-quality system. JAD sessions are usually conducted in a location other than the place where the people involved normally work. JAD are usually held in special purpose rooms where participants sit around horseshoe-shaped tables. Involving so many different kinds of people in one workshop makes how to effectively and efficiently organize the JAD session a big challenge. When a JAD is completed, the final result is a set of documents that detail the workings of the current system related to study of a replacement system. These requirements definition document generally includes business activity model and definitions, data model and definition, data input and output requirements, it may also include interface requirements, screen and report layouts, ad hoc query specifications, menus, and security requirements. When used at a later point in the system development lifecycle, a JAD session can also be used to refine a system prototype, develop new job profiles for system users, or develop an implementation plan. To exploit full potential of JAD, the groupware tools should be applied in JAD workshop sessions. When groupware tools are used in an automated JAD workshop, they greatly facilitate the generation, analysis, and documentation of information. Groupware is particularly valuable for JAD workshops conducted to define and build consensus on the requirements for new systems. Prototyping. In this video, we are going to see about prototyping. Prototyping is a means that is being increasingly used to gather requirement specifications from users. Prototyping is a means of exploring ideas before you invest in them. Prototyping allows system analysts quickly show users the basic requirement into a working version of the desired information system. After viewing and testing the prototype, the users usually adjust existing requirements to new ones. The goal of using prototyping is to support requirement determination, is to develop concrete specification for the ultimate system, not to build the ultimate system from prototyping. Prototyping is most useful for requirements determination when user requirements are not clear or well understood. Few users and other stakeholders who are involved with the system have possible designs which are complex and require concrete form to fully evaluate. Prototyping is using when there is a communication problem between the users and the analysts. When adopting prototyping, analysts should concern about the potential problems about this requirements determination method, such as informal documentation. A survey of MIS managers in Fortune 1000 firms suggests that there are 4 prototyping methodologies in use today which supplement the traditional systems development lifecycle. They are as follows. Illustrative. It produces only mock-ups of reports and screens. Simulated. It simulates some system functions but does not use real data or a database. Functional. It performs some actual system functions and uses real data and or a database. Evolutionary. It produces models that become a part of the final operational system. Another way that prototypes are classified is by the fidelity of the prototype or the degree to which the prototype represents the appearance and interaction of the system. The types are given as follows. A low-fidelity prototype is one that is quickly constructed to depict concepts, design alternatives, and screen layouts. Medium fidelity prototypes partially simulate the system interaction and functionality. High fidelity prototypes are fully interactive, simulating much of the functionality in the final product. Prototyping is found useful in a number of situations, like when the user is unable to articulate the requirements, user cannot visualize the system he wants, especially new users who have an idea of what a system could look like. When the environment is new and not fully understood by the user or the analyst, where the requirements are expected to evolve, for example, a decision support system where the user wants to have an idea of what the system can do, come up with more requirements. When the uncertainty is high, the representation of prototype model. Business process reengineering. In this video, we are going to see about business process reengineering. Business process reengineering (BPR) is a business management strategy originally pioneered in the early 1990s. BPR focuses on the analysis and design of workflows and business processes within an organization. BPR aimed to help organizations fundamentally rethink how they do their work in order to dramatically improve customer service, cut operational costs, and become world-class competitors. BPR is different from other approaches to organization development (OD), especially the continuous improvement or TQM movement. Business process reengineering (BPR) is the practice of rethinking and redesigning the way work is done to better support an organization's mission and reduce costs. Reengineering starts with a high-level assessment of the organization's mission, strategic goals, and customer needs. The diagrammatic representation of business process reengineering. Reengineering identifies, analyzes, and redesigns an organization's core business process with the aim of achieving dramatic improvements in critical performance measures such as cost, quality, service, and speed. Reengineering recognizes that an organization's business processes are fragmented into sub-processes and tasks that are carried out by several specialized functional areas within the organization. Reengineering maintains that optimizing the performance of sub-processes can result in some benefits but cannot yield dramatic improvements. For that reason, re-engineering focuses on redesigning the process as a whole to achieve the greatest possible benefits to the organization and their customers. In order to achieve major improvements, BPR is seeking for a change of structural organizational variables. BPR derives its existence from different disciplines, and 4 major areas can be identified as being subjected to change in BPR as follows: organization, technology, strategy, people. Technology is concerned with the use of computer systems and other forms of communication technology in the business. In BPR, information technology is generally considered as an enabler of new forms of organizing and collaborating rather than supporting existing business functions. The concept of business process interrelated activities aiming at creating a value-added output to a customer is the basic underlying idea of BPR. The processes are characterized by a number of attributes such as follows: process ownership, customer focus, value adding, cross-functionality. The role of information technology. Information technology IT has played an important role in the re-engineering concept. Information technology is considered by some as a major enabler for new forms of working and collaborating within an organization and across organizational borders. BPR literature identified several so-called disruptive technologies that were supposed to challenge traditional wisdom about how work should be performed. Shared databases making information available at many places. Expert systems allowing generalists to perform specialist tasks. Telecommunication networks allowing organizations to be centralized and decentralized at the same time. Decision support tools allowing decision making to be a part of everybody's job. Wireless data communication and portable computers allowing field personnel to work office independent. Interactive video disc to get in immediate contact with potential buyers. Automatic identification and tracking allowing things to tell where they are instead of requiring to be found. High performance computing allowing on-the-fly planning and provisioning. Workflow management systems were considered as a significant contributor to improve process efficiency. System selection plan and proposal. In this video, we are going to see about system selection plan and proposal. An enterprise resource planning (ERP) selection methodology is a formal process for selecting a system. Existing methodologies include Spec IT Independent Vendor Selection Management, Cupier's Funnel Method, Dobryn's 3D Decision Support Tool, Clarkson Potomac Method. The goal of system selection is to source a system that can provide functionality for all of the business processes. To get complete user acceptance, management approval, and most importantly, can provide significant return on investment for the shareholders. The complexity of selecting an ERP system is further exacerbated by the fact that some systems are geared for discrete manufacturing environment where a distinct amount of items make up a finished product. A proper ERP system selection methodology will deliver, within time and budget, an ERP system that is best fit for the business processes and for the user in an enterprise. It is used in small-scale enterprises for implement their organization towards the MAS. Poor system selection. In this video, we are going to see about poor system selection. Companies use a fully objective selection methodology when choosing an ERP system. Some common mistakes include incomplete requirements, reliance on vendor demos, overemphasis on system cost, selection bias, failure to use objective professional services, inability to understand offering by ERP vendor, incomplete requirements. It is very important to understand user requirements not only for current processes but also for future processes. Without detailed user requirements, review of systems for functional best fit rarely succeeds. The requirements must go into sufficient detail for complex processes or processes that may be unique to a particular business. Reliance on vendor demos. Vendor demonstrations tend to focus on very simplistic process. A typical demonstration shows an ideal order to cash process where a customer orders a quantity of product that is in stock. The reality in most businesses is that most customers have varying and more complex commercial arrangements and products are not always in stock. Overemphasis on system cost. The cost of an ERP system is significant for a company. Other important decision criteria such as functionality, future-proofing, underlying infrastructure, and e-commerce capability, among others, may be under stress. Selection bias. It is not unusual that the decision on which system to purchase is made by one individual or by one department within the company. An ERP system that may be excellent at one function but weak at other processes, imposed on the entire enterprise with serious consequences for the business. Failure to use objective professional services. One of the main reasons for failure in system selection is the understandable lack of knowledge within the company. Experienced consultants can provide information on all of the packages that are available in the marketplace. The latest functionality available in the most common packages and most importantly can assist the user in deciding whether a specific requirement would provide added value to the user and to the business. However, it is worth noting that the professional help must be provided by objective consultants who have no affiliation with ERP system vendors. If a consultancy has built up an expertise in the use of a particular package, then it is in its interest to recommend that package to its client. Enterprise system implementations are late or over budget. Inability to understand offering by ERP vendor. A reason for being late and over budget is that the company did not understand the offering by the vendor because the contract was signed. The reality is that there is a huge amount of work required to input data onto a new system. The vendor will import the data into the new system but expects the company to put the data into a file that is easy to import into the system. The company is also expected to extract the data from the old system. ERP to be successful requires levels of data integrity far higher than most companies have ever achieved or even considered. Inventory records, bills of materials BOM, formulas, recipes, routings, and other data need to become highly accurate, complete, and properly structured. This typical scenario is one of many issues that cause implementations to be delayed and invariably lead to requests for more resources. A proper system selection methodology. In this video, we are going to see about a proper system selection methodology. To address the common mistakes that lead to a poor system selection, it is important to apply key principles to the process, some of which are listed here under structured approach, focused demonstrations, objective decision process, full involvement by all personnel. Structured approach. The first step in selection of a new system is to adopt a structured approach to the process. The set of practices are presented to all the stakeholders within the enterprise before the system selection process begins. Everyone needs to understand the method of gathering requirements, invitation to tender, how potential vendors will be selected, the format of demonstrations, and the process for selecting the vendor. Thus, each stakeholder is aware that the decision will be made on an objective and collective basis, and this will always lead to a high level of cooperation within the process. Focused demonstrations. Demonstrations by potential vendors must be relevant to the business. It is important to understand that there is considerable amount of preparation required by vendors to perform demonstrations that are specific to a business. Therefore, vendors are treated equally in requests for demonstrations, and it is incumbent on the company to identify sufficient demonstrations that will allow a proper decision to be made. Ensure that vendors do not opt out of the selection process due to the extent of preparation required. Objective decision process. Choosing which ERP to use is a complex decision that has significant economic consequences, thus it requires a multi-criterion approach. There are two key points to note when the major decision makers are agreeing on selection criteria that will be used in evaluating potential vendors. Firstly, the criteria and the scoring system must be agreed in advance prior to viewing any potential systems. The criteria must be wide-ranging and decided upon by as many objective people as possible within and external to the enterprise. In no circumstance should people with affiliations to one or more systems be allowed to advise in this regard. Full involvement by all personnel. The decision on the system must be made by all stakeholders within the enterprise. It requires top management leadership and participation. It involves virtually every department within the company. Representatives of all users should be involved in the project initiation phase where the decision-making process is agreed. Assist in the gathering of requirements. Attend the vendor demonstrations. Have a significant participation in the shortlisting and final selection of a vendor.